Imagine a tiny messenger, a traveler from Earth, launched in 1977. This messenger is Voyager 1. NASA sent it on a grand mission to explore the unknown. Voyager 1 has a twin, Voyager 2. Together they embarked on an epic quest. Their initial task was ambitious: to visit the giant planets, Jupiter and Saturn. Voyager 1 performed its duties flawlessly. After its planetary encounters, its journey was far from over. It was set on a path to leave our solar system, to venture into the vast dark expanse, a true odyssey into the great cosmic ocean. Voyager 1's first major assignments were breathtaking. It flew past Jupiter in 1979. The images it sent back were stunning. We saw Jupiter's Great Red Spot, a storm larger than Earth itself. It revealed active volcanoes on Jupiter's moon, Io. This reshaped our understanding of moons. Next, Voyager 1 journeyed to Saturn. It arrived there in 1980. The spacecraft gave us incredible close-up views of Saturn's magnificent ring system. Voyager 1 studied Saturn's atmosphere and its many fascinating moons like Titan. These encounters provided a wealth of data. Having completed its planetary tour, Voyager 1 faced a new destiny. It used Saturn's gravity to propel it faster. In August 2012, a historic moment arrived. Voyager 1 crossed the heliopause, entering interstellar space. Voyager 1 is now incredibly far away, over 15.4 billion miles from Earth. Light itself takes nearly 23 hours to travel this distance. Communicating with Voyager 1 is a slow dance. Engineers on Earth send a command. They must then wait nearly 2 full Earth days for a round trip. The team at NASA's Jet Propulsion Laboratory are masters of this interstellar conversation. Voyager 1 has been operating for over 47 years. In the harsh environment of space, technical challenges are becoming more frequent. Components wear out, systems degrade. The spacecraft's power source is also diminishing. Voyager 1 is powered by nuclear energy, specifically 3 radioisotope thermoelectric generators, or RTGs. These RTGs convert heat from decaying plutonium-238 into electricity. The power supply decreases by about 4 watts each year. Careful power management is essential. In late 2024, a serious problem arose. Voyager 1 suddenly fell silent. On October 18th, a command was sent to activate a heater. But something went wrong. The spacecraft's fault protection system kicked in. It automatically shut down the main transmitter. The primary X-band radio transmitter went offline. Voyager 1 switched to its backup transmitter. This is an S-band transmitter. It is much weaker than the X-band, making its faint signal hard to detect. Engineers at NASA's Deep Space Network, DSN, were alerted. They began a painstaking search, trying to lock onto that weak S-band signal. After tense efforts, they found it. A fragile thread of connection was re-established. By November 2024, success. The team managed to command Voyager 1. It switched back to its X-band transmitter. Normal data flow was restored. Just when the team breathed a sigh of relief, another critical issue emerged in early 2025. This new problem was even more daunting than the last. This time, it involved the spacecraft's orientation. The precise alignment of Voyager 1 was at stake. Voyager 1 needs to keep its main antenna pointed precisely towards Earth. This alignment is crucial for maintaining communication. This is crucial for sending and receiving signals. Without this, the mission would be in jeopardy. This pointing is done by small thrusters called attitude control thrusters. These thrusters are essential for the spacecraft's stability. But the primary set of these thrusters was failing. They were becoming unreliable and their performance was degrading rapidly. The cause? Likely debris accumulation. Over the years, tiny particles had built up, causing blockages and malfunctions. If these thrusters failed completely, it would be disastrous. The spacecraft would lose its orientation and drift aimlessly. Voyager 1's antenna would drift, it would lose its lock on Earth, and we would lose Voyager 1 forever. The mission would be lost. There was a backup plan, but it was a long shot. The team had to think outside the box to find a solution. Voyager 1 has a set of reserve thrusters called Trajectory Correction Maneuver, or TCM thrusters. These thrusters were designed for course corrections. They had not been fired since 1980. For decades they remained unused, gathering space dust. For over 44 years they lay dormant. The challenge was to see if they could still function after all this time. Bringing them back to life seemed impossible. The team had to meticulously plan and execute the reactivation. In an astonishing feat of engineering, NASA did it. The thrusters were successfully reactivated. In the spring of 2025 they succeeded, less than 2 months before a May 4th deadline. The timing was critical. The reserve thrusters fired, and they worked. Voyager 1 was back on track. Voyager 1 could once again point home, communication was restored, and the mission was saved. A true miracle save was needed, and against all odds, NASA achieved it. Even after nearly half a century in space, Voyager 1 continues to do groundbreaking science. It is our only direct probe in interstellar space. Its instruments are our eyes and ears in this unexplored region of the cosmos. 4 of its original 10 science instruments are still active and collecting data. This data is incredibly valuable. It tells us about the environment beyond our sun's influence. They are investigating interstellar particles, the tiny bits of matter that drift between stars. They are measuring the interstellar magnetic field. They are also studying plasma waves. Voyager 1's scientific journey is not over. Keeping Voyager 1 alive is an ongoing challenge. This spacecraft, launched in 1977, has been traveling through space for over 4 decades, and ensuring its survival requires constant vigilance and ingenuity. A major part of this is managing its power. The spacecraft relies on a limited energy source, and as it ventures further into the cosmos, this becomes increasingly critical. Its 3 RTGs are slowly fading. These generators convert heat from decaying radioactive material into electricity, but their efficiency diminishes over time. The plutonium-238 that fuels them decays, producing less heat and therefore less electricity. This natural decay process is inevitable and poses a significant challenge. The power output drops by about 4 watts per year. This gradual decline means that the spacecraft has to operate on increasingly limited power. The spacecraft now operates on a fraction of its launch power. When it was first launched, Voyager 1 had ample energy, but now, every watt counts. NASA engineers have become experts in energy conservation. They have developed innovative strategies to extend the mission's life as long as possible. They have had to make difficult decisions about which systems to turn off to save precious watts for the essential ones. This delicate balancing act is crucial for the mission's success. Non-essential systems were shut down years ago. This includes instruments and components that, while useful, are not critical to the spacecraft's primary objectives. Heaters for some science instruments were also turned off. This decision was made to conserve power, even though it meant risking the functionality of these instruments. Miraculously, some of these instruments have persevered. Despite the harsh conditions, they continue to function and send valuable data back to Earth. They continue to collect data even when operating far below their tested temperature limits. This resilience is a testament to the robust engineering of the spacecraft. The mission team carefully prioritizes power allocation. Every decision is made with the goal of maximizing the scientific return from the remaining power. Scientists estimate that the RTGs might provide enough power to keep some instruments running into the late 2020s. This gives hope that Voyager 1 will continue to make groundbreaking discoveries. Every extra day of data is a bonus. Each additional piece of information helps us understand more about the universe, making the effort to manage Voyager 1's power all the more worthwhile. Voyager 1's journey is more than a space mission. It represents the pinnacle of human curiosity and the relentless drive to push beyond our known boundaries. It is a story of human ambition, a tale of our unyielding desire to explore. This mission embodies the spirit of discovery that has driven humanity for centuries. Launched in 1977, it has outlived expectations. What was initially planned as a 4-year mission has now spanned over 4 decades. It has traveled farther than any other object crafted by human hands. Voyager 1 has ventured into the unknown, crossing the boundaries of our solar system. It has faced down the darkness, the cold, and the immense distances of space. The spacecraft has braved the harshest conditions imaginable, continuing its mission against all odds, and it continues to teach us. Its achievements are monumental. Each piece of data it sends back expands our understanding of the cosmos. From the stunning revelations at Jupiter and Saturn, to becoming the first spacecraft to enter interstellar space, Voyager 1 has rewritten textbooks. Its discoveries have reshaped our knowledge of the outer planets and beyond. It has reshaped our understanding of the solar system and the galaxy beyond. Voyager 1 has provided us with a new perspective on our place in the universe. The recent engineering triumphs show the incredible dedication and ingenuity of the teams at NASA and the Jet Propulsion Laboratory. Their work ensures that Voyager 1 continues to operate and send valuable data back to Earth. Voyager 1 carries with it the golden record, a message in a bottle, cast into the cosmic ocean. This record is a time capsule, intended to communicate the story of our world to extraterrestrials. It contains sounds and images of Earth, a greeting to any extraterrestrial civilization that might one day encounter it. This makes Voyager 1 a cultural ambassador, representing humanity's hope and curiosity. This makes Voyager 1 not just a scientific probe, but also an ambassador of humanity. It carries our dreams, our knowledge, and our desire to connect with the unknown. As Voyager 1 journeys ever onward, its power will eventually fade. The spacecraft will continue its silent voyage through the cosmos, long after its instruments have ceased to function. Its instruments will fall silent. But the legacy of Voyager 1 will endure, a testament to human ingenuity and the unquenchable thirst for discovery. But its legacy will endure. Voyager 1 will forever be remembered as a symbol of our quest to understand the universe and our place within it.